Hey everyone, how are we doing? Sorry for the delay. I was getting a little bit of lunch, just relax for a moment. How's everyone doing? Cassandra, Warren, Casey, Warren, so good to... Oh no! We got the stream in the background. Hear myself. Who has questions? Let's start off strong right here. Jump into some questions. Make sure Mewbot's awake right there. Good to see you, Mackenzie. Little chill music. What questions do you have? Drop those questions. Yeah, Kaya, great to see you here. We're just like, I got that second cup of coffee. Got that energy. Let's start off some questions. Could we go over the Philanthropic organization? You bet. Office hours? No! Philanthropic organization. Newbot's waking up. Brian's waking up. Here we go. Some points in the chat. Philanthropic organization. Chapter 5, Part 2 quiz. Philanthropic organization. Chapter 5, Part 2. Okay, got the quiz stuff pulled up right here. Let's see, Philanthropic. Chapter 5, homeworks, question 4 and 5, you bet. The Applet, we can do some Applet stuff. We've got the Philanthropic, the Applet, and homework. We'll do that. Our brains will be rattling. Philanthropic to start. Who can put the Applet in the chat for 100 points right here? Drop the Applet in the chat. The Applet's going to be a huge help. So drop the Applet in the chat. Who knows how to have Mewbot tell us about the Applet? A philanthropic organization found it. So someone's going to drop the Applet right here as we get ready for a philanthropic organization. So Philanthropic Stat 201, Chapter 5, Philanthropic organization. Mewbot's dropping the Applet. We have right here the Applet questions, Stat 201, Chapter 5, Part 2, Applet questions, and Stat 201, Chapter 5, Part 2, homework. I think you said 4. I don't know if there's a 5 on the homework. There we go. We got all the questions listed. People are dropping the Applet, and let's do the first question. Here we go. Casey asked the question about the Canvas content. Good questions right there. Let me know about the question on the Canvas content. We can do that. And question 3, Grace, of course. Question 3. We can look at some question 3. So let's look at this one. This one's actually one of the toughest ones. Sorry, 3 and 4. Okay, I was like, I don't think there's a 5. So we can do 3 and 4. So this question right here is pretty tricky, but I want you to first notice something about this data. What do you notice immediately about this data that just doesn't work in your brain for this chapter? Like when you look at that data, you're like, that data looks a little bit like it doesn't apply to this chapter. No worries, Warren. 100 points. Don't worry, I think it's 100 points. It's skewed. It's skewed to the left. Right to the high, left to the low, whatever way the tail goes. So this is some left skew data. Remember the Monster Man. He is in full force right here. Can't draw today. There's the Monster Man. He is very, very left skew because his tail is going to the left side. Right to the high, left to the low, whatever way the tail goes. So we're probably going to run into problems with this data right here. So let's think about what problems we have. Which is the better way to describe this? Explain. It is going to be the mean or the median. So if data is very skewed, the best measure of center will be the what? If data is very skewed, the best measure of center, not of spread, the best measure of center is the this. The median. Grace, great answers right there. The median. So remember, the median is not impacted by outliers. The mean is for normal data. When we have normal looking data, we use the mean, and when it's skewed, we use the median. So the median is not impacted by outliers because the data is so skewed to the left. So what is the better measure of the spread of the data? What goes with the median? Now remember, the median is the 50th percentile, so maybe we should use something percentile based for some spread. The spread of the data for skewed data, so take a note, the spread of the data for skewed data is going to be, so if there's outliers or skew, the spread is going to be the what? Good practice right here. The spread is going to be the what? The spread is going to be the what? So spread is really only 2 metrics right here. So go to review. This is a great question for review. The spread, remember the median's the 50th percentile, so how about we do something percentile based? The IQR, Kaya right there, great answers. The IQR. If you want, try to calculate the IQR for another 100 points. So look over here and just try to figure out the IQR mathematically. And don't worry about which way you subtract. Just look at the distance they are apart. So the data is so skewed to the left, so the IQR is going to be a better measure of the spread of the data. So the IQR, we'll see if someone puts it in the chat, but you can see Q3 and Q1, the 75th and 25th respectively, and find the IQR oh, it says it right there. 100 points for Brian. It's just the distance those numbers are away. So with this right here, we need to now figure out for the normal model about what percentage of adults should have a percent white residence within 3 standard deviations. So we need to know our numbers: 68, 95, 99.7. So which of these corresponds to the third number on the empirical rule of 68, 95, 99.7, A, B, C, D, E, or F? Which of these corresponds to the exactly, Grace, right there? That is the 3 standard deviations. If it said 2, it would be 95. If it said 1, it'd be 68. So the 3 standard deviations is, and this is what we expect. It's not saying the truth. It's just saying according to the normal model right here. What all do I have open today? About a billion things. So according to the normal model, if the normal model is applicable, then within 3 standard deviations, we should see 99.7% of the data if the normal model is applicable. What percentage of neighborhoods actually have a percent within 3 standard deviations? Now, this is the tough one. This is the one I'm going to get a little worried on. If I get it wrong, you get it right, so you should root against me. So you should probably root against me and be like, it'd be really great if Brian got this problem wrong, because if he gets it wrong, then I get it right by virtue of choosing the same wrong answer as Brian. So let's look at this right here. We have the actual data right now. The mean for the data is 82. So the mean for the data is 82, which puts the mean right about here. 1 standard deviation is 20. So how much, just round, I know that's 20.1, but how much is about 3 standard deviations? 3 standard deviations, or you could call it 21, is how much data? 3 standard deviations, like find for me 3 standard deviations right now. So let's say 3 standard deviations. What is 3 standard deviations? You can round it, or you can use 20, or you can not round it. So 3 standard deviations is a little bit more than this, but about this. How much is 3 standard deviations? 3 standard deviations would be what? 3 standard deviations would be what? How much is 3 standard deviations? If I go out 3 standard deviations from the mean, I've gone how far away from it? So I'd have to go out 1, 2, and 3 standard deviations. 63, great answer there, 63. So just rounding it, nice, neat numbers. Oh, Grace went up. I think Grace went up 3 standard deviations. Great. Up 3 standard deviations is going to bring us up to here, way off the chart. And so we're off the chart right there, and then down here. So we're asking, how much of the data is contained within this bounds? Does that make sense right there? Who understands what we've done? We've gone down like 20, 20, 20. You could find out the exact point of where you get to by taking the mean and subtracting 3 standard deviations. Oops. Did I have a negative or something? Whoops. 82.81 minus 20.91. And there we are. So we're about at 20. So that looks to be correct right there. We went to the mean and went down 3 standard deviations. If you go up, you're way off the curve. So does this look like a lot of the curve or a little? Just a lot or a little? Like most of it, a little bit of it? How much have I shaded in? A lot of the curve or a little? Your thoughts on that? Like, it looks like a lot or a little. What does it look like to you? Oh, like a lot or a little. Did I shade in a lot of this curve or a little bit of it? Like, yeah, you barely shaded any of it, Brian. Or, oh, you shaded in pretty much all of it. What do you think? I would say that's a lot of it, right? I would say it's a lot. So the reason a lot is because the whole curve is the green aspect. So not like this region, but in terms of the green curve, does that make sense? No, don't worry, Grace. Straight answer right there. Don't worry. In terms of the green curve, I've shaded a lot of it. Like a lot of it's contained within these bounds. I know you'd say, well, we didn't shade anything over here, but there's no data over there for us to shade. But this pretty much has shaded most of the green curve for us. A lot of it has been shaded. So when we think a lot has been shaded, ooh, don't do that. If we've shaded a lot of it, A, B, C, or D. Remember, we shaded from here over. So do you think which of those would be the right answer? A, B, C, or D? Which of those looks to be the closest answer to, wow, we just shaded a lot, pretty much all of that curve? A, B, C, or D? What looks to be the right answer with us shading pretty much all of it? Not all of it literally, but a lot of it. A lot of it. It would be between, I'd say between A and C, right? So now we're asking, is the amount we shaded maybe in the 90s or the 80%? Do you think this is like 90% of the green curve shaded or closer to 80-ish%? What do you think? I'd say it looks more like 90-something% shaded, right? Oh no. Does this look this? So we're saying this looks around 90 something percent shaded. Does that make sense? If the answer is C, we'd be saying it looks like low 70s%. Does that make sense? And so Casey did Caesar right there. If the answer was, if it was C, it'd be between like 80 to 85%. So we're asking, has Brian shaded in somewhere between 80 to 85% of the curve? What if it's only asking about one standard deviation, then go out just one standard deviation on the curve? So then try to do your drawing right here and think about just one standard deviation. And that would look like, here, I'll draw what that would look like. If your graphic's similar to mine, it would probably, that's a lot of the curve right there. That's probably about 80, 85%, Cassandra. If 80, 85% is a possible answer, which is more than 68. For one standard deviation, I'd say that's like 80-ish%. Does that make sense, Cassandra? If yours says one standard deviation in the data is going to be similar to mine, I'd probably do about, if it has an 80 to 85 answer, I'd probably do that because that looks to be probably, does everyone understand why I'm saying that's maybe 80% or so? Does everyone follow me a yes or no on that? Like I'm saying, that's maybe 80% of the curve shaded. I know it's like hard to tell, but it's definitely a lot. It's definitely a lot, but within one standard deviation right there, that's probably about 80%. So now I just went out one. If the question were to say one standard deviation, like it's about 80% of the curve. So that's a different like variation on the question you could get, where mine says go out 3 standard deviations right here, and I'm saying like what percent is contained within 3 standard deviations. So mine is going to be the closer number to here. So why doesn't this work? Well, the data is unimodal. It better. So the data is skewed to the left. That is true. The normal can't be used. The data is not symmetric. The data is not skewed right. Okay. It's got multiple things to select. So going off the theory that it has multiple things to select, there are outliers and there's little bits of gaps. It says and or gaps. So because of the outliers, I'm going to select that. Check the answers. Oh my gosh. Seriously? If you selected there are outliers, email me and get the points. What is going on? We're going to need to re-record that. What's going on? Really? At some point, skew will become outliers. If you selected this, email me and say, I'd like my points back. So that's one of the great things about being here in office hours. But yeah, that was the only, I was like, I mean, it's definitely left skew. It's definitely left skew. It's not symmetric. The normal model cannot be used for this. It's not right skew. It is unimodal. So it should be unimodal, but it's not. I guess it shouldn't have a multi-select here if it's doing that, because that kind of tricks you. So if you got tricked like me, then as the outliers choice, yeah, I got 100. Nice job. Yeah, that's ridiculous, isn't it? We got tricked today. We don't like that. Let's head back here to the main screen. Troy, great job. We might have some time today, Alexa. We're going to do a purely dedicated stream to that on Friday. We also did it yesterday, so let me show that. In the background, we have a stream yesterday. We might circle back around to this. We have a homework due tonight, so we might focus a lot on that. But yesterday, we did an example of the visualization. So check out the end of yesterday's stream, Alexa. We'll probably try to circle back around to that. But we did a full example of doing visualization number 4, and we have a full dedicated stream to this on Friday. Alexa, let me put that on the list. We'll see. That's a good question. Stat 201, visualization number 4. Visualization number 4. Okay. Let's take a look. You're welcome, Alexa. Great job. Thank you so much for being here. Troy, Alexa, so good to see you. It's time for the next question. Next question is the Applet question, which is on the homework and the quiz. And so for this question right here, do not use z-tables. I mean, it's not the end of the world if you use a z-table, but I think you won't get as prepared for the test. So how do we get to the applet? Who can help us out with getting to the applet here? Who can help us get to the applet? I'm going to go to the applet here, but someone drop the applet in the chat. Very common question, where's the applet? We have the access to all the applets in our class by using MuBot. Right there, people getting 100 points knowing how to get to the applet right there. David M. Lane applet, MuBot helping us out, getting us to that applet right there. I'm orienting my screen for proper utilization of the applet. Okay, so the applet question. Take a note right here. Applet question at 15:05.3. Let's do this. Here we go. Okay, so this is the applet question, which really helps us solidify our knowledge on how to use the applet. When you're doing these applet questions, it's important to understand what information the applet's showing you. Now, the first thing you want to know is we're using the standard normal curve for these questions. That means everything on the curve is a what right now? Every single thing. Can you go over the quiz question? Yeah, just use percent. Yeah, Grace, let me put that on the list. Everything on that curve is a what right now? Everything on that curve is a what right now? Every single thing on that curve is a what right now? Every single thing, because this is the standard normal curve. So if you see the standard normal curve, you're like, oh, those are all blanks right now. You should be like, oh, that's a blank, which it kind of shows you over here. Those are all what's on the curves. Like, oh, on the standard normal, it has a mean of 0 and a standard deviation of 1. Every single thing on that curve is a what right now? Every single thing is a what? Like, you're like, oh, that's a blank. Z-score, Kai, right there, you see it. Those are Z-scores. So these are all Z-scores right here, which tell us how many standard deviations something is above or below the mean. We could use this to solve additional problems. Great job right there, Mackenzie, also. So now to solve these questions, you need to make the applet, links above right there in the chat, make it look like the pictures over there on the side. So the first question here is the first button. Hint, hint, hints. So we're going to go here and say, graph the area above 1.7. Now, if you think 1.7 is over here on this side of the curve, so we're going to see an image that looks like this right here, and there's the image. The answer, which is right here next to me, is 4.46. Make sure to, I usually copy it, make sure to have your decimal moved properly. So when we do this, make sure to move the decimal in right here and to make sure to do the 2 decimals. So be very careful on how you copy it. I'll disappear so you can see it. You want to, I just usually copy it, but then make sure you connect it. Great job, Mackenzie, right there. Thank you for following along. Exactly. On the live chat, great job. And so next, we want to do the area below 1.65. Now, here's the thing. Is 1.65 on the right or the left side of the curve? So 1.65, is that on the right or the left side? And we want the area below it. So if we want the area below it, we first have to know is it on the right, like 1.645, or the left side of the curve? Those numbers look a little bit different on the left side. So which side of the curve would it be on? Then we want the area below it. It's going to be on the right. We are shading to the left. So we're going to have 1.65 on the right side of the curve, but shade to the left. Does that make sense, Mackenzie? So 100 points then. Thank you for answering. Everyone's on activity 4 for yes. Oh, number Oh, John, we might hop on. Do you have a moment, John, in a little bit to hop on the Discord and we could take a look at this? You might have to reinstall our studio. So we probably need to take a look at that, especially today. We might need to hop on a Discord call, like message me on Discord and say, hey, Brian, later today when I'm finished off hours, or because I'll teach class right after this, if we could hop on Discord and I could just like view it. Yeah, Mackenzie, I ask a lot of questions. So, oh, yeah. Thank you so much. Let me go here and take a look. Yep, wait. Yep, I see you right there. First name, last name. Yeah, let me do that. Great job. No, thank you so much. But how would you find the middle? Go over here to the second part of the applet and do the percent and do the middle. So Fleming, we'll check it out here in a second. Fleming, and great questions, Fleming. Go over here to the second part, enter in the information, and then you can do the between. So that might help you out. You might be like, I got it. But we'll check it out. Probably, what time do I teach? I'm trying to think of the times I teach. Can't think, 4 Knoxville time, 4:30. 4:30, I think I finished at 4:05 Knoxville time. So 4:20, 4:25 around there. Great questions, John. And so here's the thing. With this picture, we need to go to the below button. You're welcome, Fleming. Fleming figured it out. Nice job. So watch this. Are you ready? My brain's trying to think. 1.645. Like, why is he mumbling that number? That is 90%, so 95. This is a little bit more. Oh, no. Really? Well, darn. Let's do below and do 1.65. 95.05. Really? Really? The answer, the area below a z-score of 1.65 is that. I was off by 6/100ths, and it said no. Unless I've done some other sort of error right here. It said no. So we were super close, but Brian couldn't guess that one with his knowledge. I said 95.11, and it said no. It's very close to some numbers I know on the curve that you're not meant to know. But when we do question 3, what do you think Brian's going to click to do question 3 with this one right here? What do you think I'm going to click? Which button do you think would it be associated with the answer with question 3, which asks the area between a z-score of negative 0.75 going up to 1.5. You're right, Mackenzie, right there. We're going to go to the between, which is the third button. The third button on the applet right here is going to help us do the third question. And get ready for the last question when we get to it. The third button is going to help us do the third question and show the picture. We can do question 4 next. That's a good follow-up to this one. We'll do question 4 next, which I think is steer weights, I think. So this is going to be the answer right here, 70.66. Be very careful while typing it in, 70.66. Now, take a wild guess, and actually, we will try to solve this one on our own. What do you think we will click for the last button right here? For the last one, question D, which one do you think we will pick? Question D, which one will we pick? Question D, which one do you think we will pick? Do you think we'll do button 1, 2, 3, or 4? For question D, do you think it's related to question? It says the area on a z-score. We're going to do the absolute value, right? Steer weights, yes. Let me put in all the steers in the jar there. We're going to do the outside one, which is the 4th button. Now, here's the thing. I'm going to make it so you can't see the answer. Oh, darn it. Here, wait. Can you see it? You can't see it now. Well, so if I do the area outside of -1 and 1, I want for you to just guesstimate this area, but not tell me it. Well, don't look it up yet. If you had to guess this area on the test, which this is a decent thing to guess, what would you guess for this area? We're going to see the exact answer here in a moment, and I love that we end with this one. If you had to guess this area, what would you guess? And you'd be very close, and you'd almost get it right with my Pearson here. If you had to guess this area, Barrett, 100 points, 32. Because 68% is inside of this and 32% is outside. That's super close. I don't think it's going to give it to us. That's very close to the right exact answer. I swear I didn't look. I was going to guess this. I saw it, and I was going to guess this if I didn't do it. And I'll show you. That's the exact. This finds the exact here, and if you're wondering how did people figure that out, it's because between -1 and 1 is 68. We round it to 68. And then Kaya right there said so perfectly. This is going to be 16% on either side. Now, this is the exact answer. This is like down to the decimal answer where we round it and say, well, that's basically 16%. So I kind of know 68.26 is the number, like, because I've done this a lot. But you should know 68, 95, 99.7. We would show you pictures on the test. Canvas content is the number one way to know it. But remember for this question, what's the quickest way to solve this question? Let's review. The question goes in order. Question number 1, go back to it. Question number 1 is this up here for A. Question number 2 is B. Question number 3 is C. Question number 4 is this one right here. It goes in order. Is it just the positive and the negative, or for the absolute value, it'll be the last button right here. So it's the outside of it, Mackenzie. So great answer right there, Mackenzie. You are right. The positive and negative, or the absolute value one, is the outside. So it's going to do like more extreme in absolute value than that number. So it'll be the outside right there. Does that make sense, Mackenzie? So for the absolute value one, it'll be the outside button. And this shows how to get the answer right there. And it goes question 1, 2, 3, 4. Question 1, 2, 3, 4. So a good way to like get that one right every time is to remember what way to put the numbers in, and then to understand the graphic you're seeing and the information it's communicating, and sometimes connected to your empirical rule knowledge. Great job. Excellent work, Mackenzie. More points in the chat. Thank you, everyone, so much for being here. We just go crazy with those points. Really great office hours. Lots of answers. We're hopping in here to the steers question. Fleming and everyone's like, yes. Time for the steers question. And so let's put the steers. Oh, that's the steers, right? Steers and percentiles. So we might have another steers. There's another steers question which we could do. And we are at 24. We're flying along. All the steers in the chat. Show those steers in the chat. You got this. Let's hop into it. So this one's a little bit different. A little bit more cows. This one's a little bit different. So this one does not use the standard normal. You could use the standard normal to solve this, but I don't suggest using the standard normal. I suggest putting in the context of the problem. So it says the highest 10%. Now here's the thing. We need to click the second button on the applet so where we can put in percents. But I'm going to do the following. The highest 10% is also known as the what? The highest 10% also has a specific spot to it, which I'm trying to show right here. The highest 10% is also known as the what? So the highest 10%, which has a z-score of 1.282, the highest 10%, which has a z-score of 1.282, is the what 90th percentile. Fleming, great job. Now here's the thing. If you want, take a moment and solve the answer using this information. You understand this chapter really well if you can solve using what I have on the screen. I'm going to put 30 seconds on the clock and offer 500 points if anyone can find the answer. Don't cheat with the Applet. So 30 seconds. Solve the first answer right here. Can you solve it? You really understand how to solve this if you can solve right now. We can use the Applet to find the answer, but if you know how to solve using this, you really understand the chapter. I'm trying to think what the answer might be. Okay, I've got a guesstimate of it. I'll know if you're close enough. Like if you solved it, I'll be like, okay, that seems like it's the right answer. So think what the z-score is telling you. The z-score can be used to find the answer because we know the z-score of the 90th percentile. Oh, all right, let's see if someone gets it. What is the z-score telling us? That looks to be the answer. That looks to be the answer, Troy. I was a little higher than that in my head. Troy did it. Troy knew and Troy, amazing work on this chapter. Troy, it sounds to me like you've conquered this chapter. I can't say for certain you have, but that sounds like you've conquered it. How did Troy know that? Because the z-score tells us what? How many standard deviations something is above the mean. So here's a standard deviation. So Troy took that, times it by the standard deviation. Oh, wait, we said 500. What am I doing? Troy got us the 500 points. Troy, shout outs to Troy right there. We're doing just the regular 500. And then Troy added this to the mean. So that's how Troy found it right there. Troy took the z-score of 1.282 and said the answer must be 1.282 standard deviations above the mean. Does that make sense what Troy did? Is this making sense? Like, this is the deeper level of learning where you're like, okay, wait, that's the z-score. So I just find out, I turn that z-score back into an observation. So really great knowledge right there. Huge shout outs to Troy right there. What we can do instead, though, if we want, is put in the context of the curve and have it directly tell us the answer. So you notice this does round up. We get some decimal differences, but Troy's answer is once again here of 1,266.1. Yes, exactly. So whenever it's asking for a specific percentile, we're probably asking for that observation. And so for the 20th percentile, try to do this. Let's try to do Troy's way. We're doing a deeper way of learning. For the 20th percentile, let's just look at it this way and see if you can find the answer to the question right here using the z-score. So this is we're trying to solve with the z-score now. Use the z-score. Another 30 seconds. Try to solve this right here. 30 seconds on the clock. Use the z-score to find the answer. You won't have access to the Applet on the test, but you could have a picture like this. You could be presented with all this information like this. It could tell you the z-score for the 20th percentile. So use the information on the screen to find it. We'll confirm it with the Applet. But there's the z-score for the 20th, and you could get all this information, the mean, the standard deviation, and here's the z-score. So what are we going to do with this z-score now? We're trying to have a deeper understanding right here. We can solve it. We can just put the mean in. We can put the standard deviation. And Troy's dropping some great knowledge in the chat right here. So Troy's got the formula. He says observation equals mean plus z-score times standard deviation. So let's use Troy's formula in the chat right there. He says we need to take the z-score of negative 8.42 times that by the standard deviation of 89, and then we're going to add this to the mean. But remember, it's a negative, so it's going to be subtracted. So let's make sure we add that. So it's a negative. There's the answer. Now here's the thing. At least right now, we can just plug in the context, which is this right here. We're trying to make sure we have some higher levels of solving too. Now, these are just decimal differences because sometimes the Applet's going to be more accurate by carrying more decimals for us. And so this is the answer right here, 1077.1. We'll do the last one the easy way right here. Because if we want the middle 40%, what button do you think I'm going to click? Button 1, 2, or 3 for the middle 40%? What button will I click here for the middle 40%? Button 1, 2, or 3? Which button do you think I'll click? We're going to do the easy solve of this to just get the answer immediately using the Applet. What button looks to get us the middle 40%? Button 3. Fleming, great job. Already solving this one, right? Excellent, Fleming. And so now I need to change this to 40, and it'll show me the spots of the middle 40. and we just go here and we put in the numbers as follows. Just make sure to copy paste them accurately and round up where appropriate. And that should do it right there. So hopefully this question seems a bit easier. Without the applet, this would be super tough. If you're using a z-table, it's a lot tougher. But understanding we could use z-scores to find these answers is pretty important. Like, gives a deeper knowledge and preparedness for the test. But Troy, I'm just so happy you're here, because I know, like, hey, David, great to see you here. Drop any questions if you got them in the chat. One thing that people always tell me is a lot of times with this chapter, there's almost like an aha moment where it just all starts to click. So for the first one, we did the 90th, and then for the other two, we used the actual percentiles. We could have used, so here's the great answer. Mackenzie, thank you so much for asking this. For this, we could have done the top 10%, and we could have asked this. So it's important too, and you see that's still the first answer. It's important to see the different ways that the applet could show you the answers. This is now using 10% and showing the highest 10%. But watch out, is this still showing? So this is where we get tricky on the test. Is this still showing the highest 10%? And you could look here to confirm. Yes or no right now, is this still showing the highest 10%? What are people's thoughts on that? So this might say, use the picture to find the highest 10%. Is that the highest 10%? Is that where the highest 10% is at? What are people's thoughts on that? Is that where the highest 10% is at? So you have to think, what is this picture showing me on the test? So this picture right here is the middle 80. Is that the highest 10% over there? The answer is, if this is the middle 80, then that's 10% here. Ooh, that's the highest 10%. And that's the 90th percentile. Like, this spot right here is where so this is the highest 10% still, because does that make sense? Like, knowing that if that's the middle 80, that's still the highest 10%. Like, that spot right there is where the highest 10% is, also known as the 90th percentile. So this is a good, like, review and being like, what does this image show us? Always try to, like, draw on the image. Yeah, Kaya, good work right there. So this is where we try to, like, shore up our knowledge and be like, if I saw this on the test, is it showing me? And the number one thing to do is to draw on the graphics. I say that, but we'll have to, like, write it down because we're taking online tests. But when I give tests in person, the people who drew on the graphics usually did really well. And then I'd look and someone would not draw on the graphics. I'm like, oh no. And they're like, I didn't see how to do it. And I'm like, draw on the graphics, draw on the graphics. And it doesn't help after we take the test. But when you're taking the test, be like, okay, I got to, like, draw this out. I got to write what it says. If it says that 80% is in the middle, I need to draw that. And then I need to find out what's the remaining. Okay, wait, that's where the top 10% is. Even though it's showing me the middle 80, that's the top 10%. It could also be shown to you this way, to show you the middle or the outside 20%. So just watch as the graphic looks virtually identical. Because if this is the middle 20%, each of these black areas right here would be worth what? Like, excuse me, not middle. If this is the outside 20%, then each of these areas would be worth what? Like, this is the outside 20% being shaded in. That is the outside 20% being shaded in. Thus, each of those areas right there is worth what? Exactly. And Mackenzie, great work. This is what we need to kind of realize, especially we get presented with test questions that show us this, is that if this is total 20%, then each of these is 10 because of the symmetry. This is the middle 80 now, and it's still the same answer. So you could get this answer. My point is to show you can get this answer a lot of ways. And then just understanding what the applet's telling you and what it means is very important. What's the next question? Let's hop into it. Exactly. Troy is just throwing down tons of help right there. I'm going to put on a different song. Troy is just giving, like, perfect advice. I think the best thing to do on the exam will be to draw the normal distribution, write down some basic values, and also write down the formulas for finding observations and z-scores. Start out your exam with that. Take your scratch sheet. You can't have it start written on it, but I would say draw the normal curve on your scratch sheet, draw your z-scores on it. Whenever you get to a problem, then do that. Shivam right there says, can you do 2 and 3 on the BS assignment that's due this week? Yeah. Currently, we're on question 7 on the BS percentile. I think we got open questions right now. Let's see. We just did the steer question. So let's see right here. We've got, first question was, David asked about and so drop the questions at any time because we're always going to list the questions. Q7, so BAS 475, Q7. This is assignment 3. We're going to do some time series. Question 7. And then we got BAS 320. We've got here assignment, I think it's also assignment 3. Assignment 3 and question 2. Okay. There we go. Got everything organized. Let me get the assignments open. Drop more questions if you have them. We'll put them ready to go Thank you so much, everyone, for being here. You get to see some time series right now. So we're going to open the time series assignment. Oh, is it over some white noise? Question 7's late in the assignment. We might be talking about some white noise, which is what we're going to do in class on Thursday. Where's the assignments? Doesn't show the calendar on here. Here we go with some time series basics. Get the assignment open. You're welcome. Hey, Vinny, good to see you here. You're welcome, Mackenzie. And great work, everybody. Let's go check this out. What time is it? 35:40. Okay, BS 475 time series basics. You can always go to the chunk you're working on by clicking the button. Oh, we got some season. I like this question. So it says we should use autoplot, GG season, GG subseries to compare the differences when it's asking about a specific way in a certain percent. We're going to put the question you have, Grace, and we'll do it here coming up after 3:20. So drop the question, whether it's the steer question or the IQ question. Let me know which one, and we'll do that for tool one. You got it, Grace. So we're going to look at some time series data. Now, if we have time series data, what must both variables be? If you were in the morning class or the afternoon class day, you heard this. For time plots, a time plot is going to be a what visualization of data? So let's look at a time plot right here. So we're talking about time plots right here are special kinds of whats. A time plot is a special case what plot? Steer question number 5 on the steer questions? Oh, yeah. Steer number 5. The other steer question. Yeah, we'll do the other steer question here coming up. You got it, Grace. Time plots are special case whats. All time plots are special case whats. Like anytime we say a time plot, we love the steers. And this is 201 related. You might say 475, but we learned this today in 201 in the morning. They're all bivariate quantitative, right, David? So you can see right there, bivariate quantitative, 2 quantitative variables, quantitative, QQ. 2 quantitative variables make a scatter plot, and scatter plots, you can have a time plot if it has time on the x-axis. Now, we can look at certain trends in the data, or we can look at certain seasonality in the data, or certain cycles in the data. So we have terminology for this, and we can view different plots. So we made this applet at the end of class yesterday to kind of look at the differences in the data and talk about what's going on to explain the data, visualizing it. So let's look at what it wants us to look at for this question. Use the US arrivals data. So you need to make sure you have library FPP3 opened up. This is basically just a data set worth of stuff. I probably have it running. I do. US arrivals is here. These are the people arriving to US from different origins in each month. So the first thing, so it compares quarterly international arrivals from to Australia. It's not US arrivals, it's Australia. Lorenzo, great to see you here. 100 points, Lorenzo, in the chat. So we've got arrivals to Australia from Japan, New Zealand, UK, and US. So let's take a look and to compare the differences between the US arrivals for these 4 countries. So let's just go to autoplot. It's a little bit crazy. We got something going on right here, first off. Now, I'm not loving this plot right here. I think we can do the facet. Let me go to the facet. There's a way to do a facet on it. I'm going to go cheat, look at the book, and do a facet of the plots. But the book is such a great help. But what do you notice? Look at the green plot right now. Put a memory in your head of the green plot. So let me go to the time series graphics. Let me do a facet of it. So he's got really good like facet plots in here. Where does he do that time series facet plot? Oh, there we go. No, that's just the different ones. These are ones we do in the notes. Scatter plot. So he does a facet on it. I know he does. I know. And there's a facet, but that's sure. Facet grid right there. There it is right there. Grid, var, state. Okay, cool. So that's how we do it right there. He's using ggplot. Okay, we'll do a ggplot. Okay, let's take it. Let's take his code. And so what do you notice about this right here? I noticed some stuff. This should get us... We're not using the visitors data. And we are using the quarter as the X, trips as the Y. And if we run this right here, we should get a ggplot of it. It doesn't like it because it's saying the variable not selected, because the variable is the arrivals. So is it going to do it now? It's all kind of mad. We probably had the facet grid to our plot variable, the vars, is that they are doing it by state. I'm kind of like trying to copy their work. Great way to do it right here. So he's taking visitors, storing a datorum, group by state. Very seasonal. There is extreme seasonality to this. But what do you also see right here? I'm trying to make a nice plot for this. What do you also see with the green plot? Like the green exhibits it. Maybe there's a cycle right here with UK. You could easily just go down to parts of this. Like if we just go the easy way of doing this, we could go to filter. Like this is the easy way. Filter, its state is it? Let me look at the variable name. Origin equals Japan. There we go. Oh, what is going on? What is it mad at me about today? Oh, we're using autoplot. Haha. Oh, that's probably part of the issue. Whoa. Slow down, Brian. Now let's autoplot it. Okay, I think that might have been part of the issue. Okay. So now we're looking at just, and there's an upward trend. This one has a cycle. Like the trend has changed in this. So there's seasonality to this for Japan, UK. That's got some trend, very strong seasonality. USA. There's no USA's at US. So a lot of these have a trend. I'd really like to get my facet grid. So let me try to get that code on here. Because it looks like we should just be able to take, I'm just going to take the code like this. And so we've got the data set. Here's this. Aesthetic, y equals trips. We're not using trips. We're using arrivals. And that should, let's see if it likes this. That works. Cool. Facet grid is going to be by origin and scale free y. Let's say trips to Australia. And let's just say count, because I don't know what units in. Counts right here. There we go. That's what I was trying to get right there. So a lot of times the book has such great ways of doing stuff. I might try to color it in here in a moment. But this, you look at a plot and you say, you know, I want to create something like this. So now we've got right here the different plots, and we can kind of compare and contrast. Does this make sense here, David, that this is where we're trying to go with this? It's like, let's get all four of them. So we might even change counts to like number of arrivals to something like that. So yeah, and this is the goal, is like, you know, when you're working with your data, we might be able to go to color, facet grid. Let me see if it has a color. It does. Cols equals red, green, blue, yellow. Oh, what? What'd I do? It's mad about something. Is Cols not what I thought it was? Cols must be null or vars. Oh, it's going to be... Okay, I think it wants a variable for Cols. I don't usually use this. Vars equals origin. No, come on. That'd have been so cool. Really? Facet grid can only appear in the row or cell, not both. Geom line. Oh, wait, let's go here to aesthetic. Col. It's not col? Let me look at ggplot real quick. I want to make this look better. I wanted colors. I want colors on this. And we'll try to see. Hey, Shannon, good to see you here. Oh, sorry. You're in biometry. Sorry, I don't tutor that. I do not know that topic. Color with the British spelling. Color. And that is outside the aesthetic. It's in the geom point. Geom line, color equals red. Oh, we've done it. We've done it. We might see something interesting here. Color equals red. We need to do a vector of colors. Red, green, blue, yellow. Oh, come on. What is the length of the data? I know why it's mad about this. So it's mad about this right now, David, because it's the amount of the points. It says there's must be the same length of the data, 508. So let me look at the data length real quick. The the Australian arrivals. So length, oh no, on number of rows. I really want to make this look all pretty right here. 508. So, okay, here's the good news. So possibly, I might be able to get this to work. Okay, so we want rep this. Last try on getting this to look all pretty right here. So I'm repeating the color that many times. There's probably an easier way. Last try, because I really want it to look pretty. Green, blue, yellow. Oh, what is the same length? Oh, 508. 508 divided by 4. 127. I can't math today. I thought it was 408. There. We've done it. There might be a line width option too. Geom line. Geom line should have an option for line width equals 3, 4. Why not? Yes. Yes. I don't want that crazy. There we go. So I would say that's looking kind of nice-ish. Or like when we put this in our thing right here. And so we have now created a decent looking graphic that I kind of like. So we got the trips to Australia. We're going to fix it up a tiny bit more. So we're just trying to make a really nice communicating graphic right here. GG Easy. GG Easy is a library that makes everything easy with ggplots. So if you put on a title right here, we should be able to go plus easy center title. And when we run that, it should do that. We're going to save the graphic into P. And then we're going to go ggplotly of P. And we get a plotly of this. And now we get a nice, cool, interactive graphic that someone could hover over, and we could put this on a web page. So this is our kind of final result right here to at least talk about this portion. So David, what are your thoughts? This is kind of what we're going towards. I might make the lines not thicker, but there's endless options. That's the thing when you're working with this. It's like you just start building, and you're like, you know, I want that title to be center. You know, oh, I'd like this to look like this. We want to make great-looking graphics. This is what we cover in 201 with the pivot chart assignment. So we've got a comparison right here of all the different countries. So we can look at it. You might say we probably should do the same scales. I could probably work on making those the same scale. Or you could just adjust the scales yourself on these. You could just say, let's change the scales of these. Because every one of these, you could zoom in on certain aspects of it to talk about, let's just look at after the year 2000, and you could zoom in on those portions of the data. And that's really what's great about these ggplot options right here. Beautiful, I agree. And that's what you're going towards. There's line style. What is line style? PCH, I think. So let's go here to PCH equals a vector of 1, 4, 5, 7. I don't think that's it. What is line style? Is it line style in R? Line style in R. This is the last one. Is it LTY? LTY line style. So, oh, and now we've got different line styles or not. Oh, we have to rep it again. Really? Really? Oh, yeah, let's try one last thing. We're doing different line styles for the fun of it. All right, so that's that. Oh, wait. There we go. Okay, cool. Just trying one last thing right here. Okay, line style 1. We don't need different line styles, but we're doing it. Line style 3. And I have an error in my code. Where's the error? It's mad about something. Oh, the geom line isn't ending. Geom line needs to end. It's mad about the geom line ending. Okay, cool. If it doesn't work, I broke it. That's okay. I don't know. I don't love it. Not the changes, and the textbook is free. Exactly. Textbook's 100% free. That's what we love about it. ggplot's getting mad at me right here, but I mean, is this? I don't know. I'm not. Whoa, that's cool right there. I would suggest against what I've done. We kind of want a continuous line when we look at data. So I'm not the biggest fan of what I've done right here. But it just shows you the endless options of what we could do. So we've got the regular line, the different types of lines, like a dashed line, a smaller dashed line, starred line. So there's many, many different options right here. But yeah, check it out. Think about ways to communicate this. And I do want to say this, check out the end of class. This is kind of a start to number 7. Funfetti everywhere. And so the biggest thing, what you're going to do now, and this is why we like to modularize it, is probably, I wouldn't suggest this. You probably just want to do the facet or the GG seasonality. You probably want to use filters for the next step of this. Oh, I love that. Filter, origin equals Japan. So now we're just going to go here. And the idea is to then communicate what you see. GG subseason. I think subseason will do it. Here we go. So here's the other plot to look at. Like when you look at this, you can see that Q1 has higher arrivals. This is showing us the seasonality of it. So we can see the seasonality right here that Japan has risen in trips in the early 90s, then dropped down. So that's the big things to be able to communicate. So think about the graphics you can make right here to communicate and just try to make really nice graphics. Like try to be like, I went too far with it. I went too far. Never go too far. So that's the goal right here, David. Let me know if you have more questions. Just think about how can I make this? How can I communicate this? And the book right here, FPP3, Forecasting Principles and Practices, is FPP3 or FPP3. Ubot knows the answer. Has great ideas, and you can use them as jumping off points. Ooh, a correlation matrix. We just did this in 201 today, correlation matrices. Then you'll see the end of kind of the assignment right there. But the book right there has all different codes, and you can use them as jumping off points, and you can answer the questions of like looking at the different groups right here. But there's pretty much all your answers and questions can be done right here, lag plots and all that good stuff. But great stuff. Let's head back here to the main screen. Oh, thank you, David. That's great to hear. That is great to hear. That is awesome. I love it. I love just doing different sorts of visualizations, taking a look at what we have in data. It's just fun to explore data to me. Like, I love making graphics. It's just fun. It's like, it's creating. It's you know, you get to explore and be like, let me do something. Let me make something. So we are going to pull up the associations part 2 assignment, do one of those questions. Let's take a look. Okay, we're doing some BS 320, then we're going to hop back here and do more steer stuff. Got more than enough time. So, 52, 41. Here we go. You're welcome, David, and great job on those points. Let's throw out some more points and hop into this. Here we go. Okay, we're going to clear off our graphics, clear off our code, and start anew. We'll be doing some more steer stuff after this, so 201, stay tuned. So here we are with the associations assignment, and we're going to do question number 2. Let's hop down here to question number 2, right here. Okay, we need the book. And to get to the book, we need to go to the course page. And on the course page, we need to go to the modules. Let's bring that over here so we can see it. On the modules, we are going to go to the homework packet. There we go. Click the homework packet, download the homework packet, open the homework packet. And we don't have to buy the book. Always a nice thing. So here's the book, ready for us to go. And let's look at the question. It says exercise 6C on page 72. Oh, page 72. And exercise 6C. Use the data records to talk about the bill and tip amounts along with the tip percentage, as well as the party size, who was at the table, whether they smoked, and the time of the visit. So we're talking about a restaurant right here, and we're trying to understand how much do people tip, very important if you work in a restaurant, and what are the factors. We are curious whether there is an association between the size of a party and whether or not they smoke. So we're going to look at the size of a party and whether or not they smoke. Party sizes range between 1 to 6. So if this is the case, is this the right one? Don't check I'm doing the right one right here. Oh, exercise 6C. I was like, something's odd. So it looks like we're doing 6C. Yes. Good. Good. Okay. Let's do this. Here we are in exercise 6C. I was like, this is not correlation. So I was like, something's wrong. Examine the association between bill and tip amount. Why did my 201, you should know this too. So 201, good question. Something started to go off in my brain when I was like smoker and this. If we're doing correlation, which is what we're doing, both variables need to be what? So this is what we're covering today in class, morning class or afternoon class. If I'm doing correlation, which is something I'm about to do, we're about to talk about either Pearson or Spearman correlation. What are we needing? So Shiv, good question right here. If we're doing correlation, There was an alarm going off in my head about this one being like, smokers, something's wrong. We're doing correlation this week. So both variables what? Very important for correlation. Both variables need to be what? When we do correlation, we need what with both variables? Like if I'm talking about correlation, I must have what? This is very important to know. Like they're good review things. Anytime you're doing a homework, be like, it should reinforce knowledge to be like, oh, wait a minute. The question we're working on, because this is correlation related, means we need two quantitative variables. Two quantitative variables. So we need to have two quantitative variables, which means variable 1 must be quantitative, variable 2 must be quantitative, and that was an issue I saw as I looked at the wrong question. So Bill and Tip is quantitative, so correlation like Pearson or Spearman will apply to this topic. So we want to create a graphical analysis using the associate. Which measure Pearson versus Spearman is appropriate to measure the strength of the relationship? Is the relationship statistically significant? Does this affect our choice right here? Let's see. So we're going to kind of do this question, but do it a little bit differently. Oh, Kristen, great to see you here. You're never too late. Drop a question in. I think we have one more question. So we're open questions after this. We have one more question after this. So give the question. Let me know. So what we're going to do right here is we're going to do a similar version of this question, but not quite this question. We're doing a similar version, but not quite this question. So I'm going to work a similar version, but not quite this question. So we get good practice. Another practice problem. So similar, that's right here. Similar version, but not quite the same. I just read, oh, that's awesome. Yes, you can rewind the video live. Good stuff right there, right? So we're going to work a similar, but not quite the exact same version. So similar question. Okay. So how about we go right here and we talk about some survey 9. I've started to switch. I use survey 10 so much. So I'm like, why not look at a survey 9? Okay. So we are bringing in the data so we can look at it. Data loads up data that's already inside of R. It's not like a file on your computer. It's already inside of R. It just kind of brings it to the forefront for you. And attach makes it so that we have these vectors attached to the global environment. So now when I type something like X01 ID, it shows up and I can see the IDs of everybody. Or if I type X04, I can see the desired weights and those individuals right there. How to find percentiles in the normal curve? Yeah, Kristen, let us know. Which one? Is it a specific problem you're wondering about? We can do that here next. But yeah, mention the problem by name and then I'll work that one and hopefully that'll help out. But yeah, we can do that next. That is up next then. So check this out. The associate function will allow us, let's go look at some survey 09. Maybe there's an association between how much people work out in their, no, let's try to find one where one exists. Number of classes missed in your GPA. This would be interesting. So we're going to look at, can your GPA, I saw GPA back here somewhere, GPA, which I think is 07 for this one. It's 11, so we got 2 surveys loaded up that are causing issues. Can your GPA be explained by how many classes you miss? Where was classes missed? It was like numbers of classes you missed. X39. Can your GPA be explained by the number of classes you missed? This is from the Survey 09 data. And here it is. Too large. Ooh, somebody's missed a lot of classes. Well, what are the conditions for correlation? Question 4 on the chapter 5. Yeah, I could do it here. We do some steers again. Yep, the steers. Yep. We'll do both steer questions after this. So it'll be a good practice here again on both steer questions. What is the problem here on this correlation? So what do you notice immediately about this, which I'd really like to know how someone misses like 150 classes. What do you notice is a problem with this correlation? So what are your conditions of correlation? QQ, is it 2 quantitative variables? Straight enough. The last condition is going to be the issue. This is a good Stat 201 question for why do we have problems with this correlation? This is a good Stat 201 question. What is the issue with this correlation? And it's very apparent. The issue with this correlation is very apparent. The outliers, Fleming, great answers. QQ, straight enough. No outliers. So what's interesting is we have ways of handling this, and I wrote some big notes on this in a previous video. So I'm going to pull up the notes we have. We could go like totally meta, Brian, right here with using like video within video within video. But we did, during the weekly activity, a really good review of this. And let's bring up the notes. So here's the notes we need right here, right here. Okay. So these are the notes we need. We'll just hover over past Brian right there. Outliers can do anything. Fleming got some notes right there. So this is what you wouldn't know in 201. Well, what is a requirement? You will know this in 201. So this is good review for 201 too. What is required of doing linear regression? If we are doing linear regression, we are required to do this. If we're doing linear regression, which is what we learned in 201, which is called Pearson's regression, it is required that linear regression, because it is called, this deer's got everyone. So if we're doing linear regression, it is required, which is Pearson's. So Pearson is required that it be what? It is required that it be what? You only need to know this one for 201. This is the only one required in 201. This is Spearman over here. So it is only required. Steers are the hot topic of the day. You got it. Pearson is required that the relationship be linear. QQ, straight enough. No outliers. And then we will talk about later on, plot doesn't thicken. We don't get into that right now. We'll talk about that more in chapter 7, test 2. So really at this point, you should think, is it two quantitative variables? Is it linear? Are there no outliers if you're in 201? But in 320, we have an additional type of correlation. The additional type of correlation in 320 is called Spearman. So Spearman. So Spearman correlation is kind of a response to Pearson. It's called Spearman rank correlation. Spearman can handle a non-linear relationship. Spearman can handle outliers. Spearman can handle heteroscedasticity, which is plot thickening, differing thickness. But it has one requirement, that there be a monotonic relationship. So think about this. Pearson is what you need to know in 201. So if you're in 201, you're learning Pearson correlation. It's just a certain kind of correlation. We usually just say it's correlation. But usually if someone talks about Spearman, they'll say something like rank correlation or Spearman rank correlation or Spearman correlation. If someone says correlation, 99.9999% of the time they're talking about Pearson. It should probably be distinguished if you're saying Spearman correlation, which is a different kind of correlation. So when we think about this, we need to be asking, don't want to full screen the chat. We need to be asking ourselves, are there issues with this? Do you see issues with this right here? Yes or no? Do you see issues with this? Yes or no? Does it look like it has issues that Pearson's going to be mad about? Yes or no? Does it look like, so 201, you might be learning an advanced concept right here. Does it look like this has issues, or nah, that has no issues? Does that have no issues? Let me see here. Does it look like it have issues or no issues? So like, it's got some issues, or nah, that has no issues. What do you think? Issues or no issues? Would you be like, yeah, it's got some issues, or no, it's got no issues? I would say this has issues. And because it has issues, we're actually going to see a stronger Spearman correlation. And the Spearman rank, there's outliers, right? That's issues. And so that's where we see a stronger Spearman rank correlation. And what's interesting is both of these correlations are negative, which shows us, and especially the rank correlation's higher, we see, it's awesome. So we see here that there is a higher rank correlation in each therapy. There's a stronger Spearman rank correlation right here, which indicates to us that there is some sort of negative nonlinear association between skipping classes and your grades. So you might say, well, what about those outliers? Those outliers are causing issues. Those outliers are dominating the relationships because outliers can do anything. Remember, and if you're in 320, Spearman can handle outliers. So Spearman is a way to basically handle outliers. Since outliers can do anything and basically just run haywire on us, we have a way of handling outliers with Spearman. So that is a big thing. We need to know that Spearman can deal with those outliers and downweight them. So this is kind of a review of the topic when we talk about, is something statistically significant? Oh, does 201 know? What should we look at? If things are statistically significant, we should instantaneously look at the what. If things are statistically significant, we should be looking at the what. To tell if something, this is what we'll talk about today in class, we should look at the what for statistical significance. So you learn these same things in 322. So a lot of times people go to 320, they're like, wait, we already did this in 201. If we want to ask if it's statistically significant, we look to see if the p-value here is less than 0.05, and both of these are statistically significant. We have, in Fleming, excellent work. This is what 320 covers. It's like, let me look at the p-value to see if it's statistically significant. It is, because it's less than 0.05. And then we are confident because 0.05 is not in the range, which means we have a conclusive interval. That's something we cover in 320, but great job. I'm throwing out a big 500 points because I really appreciate 201. You're not even in this class, and you guys aced it right there. A lot of topics that we'll be covering if you decide to take 320, or you're like, hey, this coincides with my 201 knowledge right here. Head back and do some steer questions. Okay, it's time for more steer questions. Oh, chill music. Steer questions. We learn all about steers in 201. All about steers. Going back over here to the homework. So the number one thing we need for the steer question is what? And we'd be given pictures of this on the test. So they're confusing you. Boo, also boo steers. Ranch music. I wish I had some ranch music. We'll click a random button. You ready? There's the ranch music. What do we need? What do we need for these steer questions? We got our ranch music playing, apparently. What do we need? The normal curve. Where are we going to go for the normal curve? We need the normal curve. Where would we go? Who is our man for the normal curve? He didn't invent it. It was actually Gauss who invented the normal curve, called the Gaussian curve sometimes. Who is our man who invented an applet? You know him right there. Kristen knows. Mr. David M. Lane of University of... Where's he from? He's from a different... I used to know. David M. Lane, normal curve in the chat. Let's go check out. Let me put a timestamp right here. We're going to go to 106:55. Stat 201. Chapter 5, Part 2. Steer question. Let's go check this out. Okay. So here we are with the steer question. And so the number one thing to know, and we did a more complicated solve of this last time, but let's go straight for the solve this time. When we do the steer question here, we are seeing right now the standard normal curve. Now, if you get this on a test, one of the best things for you to do is to take these numbers and draw them below the curve. What I mean by that is you could put the mean at the center of the curve. So I'm going to disappear so you can see it a little bit better. But you could put the mean at the center of the curve by just going right here. I'll explain why I did that in a moment. And putting in 1159. Now that's at the center of the curve. Now the units we go up and down are going to be the standard deviation of 87. So notice here how each time now it's going to be a unit difference of 87. No, Kristen, you're not dumb. 100 points. Because you're like, wait a minute. This is going to give me the answers. You figured it out. That's awesome. That's what we want. Because now what we have is a drawing that shows us everything we need. We just need to find out where is the top 10%. And the top 10% is going to be the highest 10% on the curve right here. So we'll round it to 1 decimal place. And there we go. Check the answer. 1 decimal place rounded. The lowest 20% is going to be on the bottom right here. And now we have this. Remember, on the test, you will see pictures. So understand what it's showing you when we say this is the 20th percentile. And we have the answer right there. Now, the middle 40 will be this button right here, but we want the middle 40. But I'm keeping down to where... That's awesome. I might hop into... I have a meeting request, so I'm going to probably jump into that. And that should do it. So this is due tonight. We've done a lot of the different versions of these problems on here, but always, if you're stuck on a question, let me know. I'm going to end office hours a tiny bit early because we have class here in 33 minutes. But let me know if you have questions. We'll be starting class here in 33 minutes. Puppet Shark, we're ending a little early. We'll be back here soon, everyone. Until then, bye for now, everyone. Bye. I'll be back. Swing by class. Be back in a little bit.